Hi everyone. In this video we're going to walk through how to enter the BTU factor for cooling and calculate the total BTU gain on the cooling section. So where are we going to get the wall BTU gain factors and the ceiling and floors? Well, like before, it's on the back of this worksheet. I'm going to go there now and show you kind of how I got the information. I'm highlighting it so you can see exactly how I'm doing it. So again, in this example, we're using no insulation in the walls. So again, older homes pre-1970, before there was an energy code and standard, homes weren't really required to set a certain insulation in the walls. So this is going to be the no insulation BTUs that we're gaining through the walls, and we're picking 105. This column here I have highlighted and circled with this blue circle here. We're picking 105 because our design condition was set at 103, so you can round up to 105 for the cooling outdoor design temperature. So 105 degrees, we are pulling in 11 BTUs in through that wall every square foot. And for the ceilings with no insulation above the ceiling, we're going to be adding or gaining 14 BTUs per square foot. And for floors, we pick the concrete slab, unheated. So this one, BTUs per foot or perimeter. And if you notice this one, we're not gaining any BTUs on the floors because the floors stay relatively cool. So in other words, they stay below 75 degrees. So that's a good feature for cooling when we use concrete slabs. So the main 2 points we're going to bring in are the walls and the ceilings and floors for cooling design calculations on that chart. So we're going to go back to that chart here. So let's go ahead and put those in now. So 11 BTUs per square foot, 14 BTUs per square foot for the ceiling, and 0 BTUs on the floors. All right, and for the windows and doors from table B, because table B was our cooling heat gain through our windows and doors, we have 8,705 BTUs that we're gaining. So 8,705 BTUs that we're gaining through windows and doors. And now we're going to take the square foot of the walls, our net walls, of 1243 times 11. So 1243 times 11. And our BTU gain through the net walls is going to be 13,673. For our ceiling, we're going to calculate 1,280 square feet times 14. 1,280 square feet times 14 equals 17,920 BTUs that we're gaining from the ceiling. And the floors, we're not gaining anything, so we'll go ahead and put a 0 because it would be 1,280 times 0, it's 0. And we have 4 people. People assume 2 people per bedroom. So this one, I believe we said it was a 2-bedroom. 4 people times 300 equals 4 times 300. 1,200 BTUs for 4 people. And this one here is a given. It's appliance kitchen load. So all your appliances, your refrigerator, your microwave that you have in your kitchen, it's roughly 1,200 BTUs that we're adding from those appliances. And so now what we're going to do is we're going to calculate the BTUH gain column. So from the windows and doors, we're going to add this. From our ceilings, we're going to add this. Our walls, our net walls, we're going to add this number. People, we're adding this. Our kitchen BTUs, we're adding this. And that's going to give us our total sensible heat gain. So let's do that now. So 8,705 BTUs plus 13,673 plus 17,920 plus 1,200 plus 1200 again. That gives us 42,698. Now we're going to take 42,698 and we're going to multiply it by 1.3. Now 1.3 is our latent load factor for cooling. So this is adding the moisture content that needs to be removed or that is added through heat gain from our structure. So that right here, this section has added up all the sensible heat, but there's also a latent heat component. This would be a given constant for latent. This is the number we're going to use for this worksheet. So let's multiply 42,698 times 1.3. We're going to do that now. So 42,698 times 1.3 equals 55,507 BTUs heat gain so far. And finally, our ducts, most of the time they're in an attic or an unconditioned space. So our duct gain multiplier of 1.1. So we're going to take 55,507, multiply that by 1.10 or 1.1. Let's do that now. 55,507 times 1.1. That gives us a total heat gain of 61,057. We could round it to 58. 58 BTUs an hour. So this is our total heat gain that we are gaining in the summertime. So we need an air conditioner that can remove roughly 60,000 BTUs an hour. That would be a 5-ton. But this is how you calculate or work the cooling section to figure out your total heating gain for cooling. If you have any questions, email me, text me, or ask me in class. I'll see you later, guys. Thank you.